Okay, so with remainder theorem yesterday, it stated that if we took whatever x equaled and we plugged it in, whatever would be left over would be the remainder, right? That was remainder theorem yesterday. So for factor theorem, I want you to copy this down. Yeah, I'm going to reset it again. 3.3, the factor theorem. The factor theorem is very similar to the remainder theorem, except the remainder is 0. The divisor is, if the remainder is 0, then the divisor is a factor of the polynomial. So a polynomial p of x has x minus b as a factor if and only if p of b equals 0. Oh, yay. Just reset it. It's still like an inch off. That's okay. So if you ever read is a factor anywhere in the question, is a factor, that means the remainder is 0. If you ever read is a factor, that means the remainder is 0. You don't have to write any of that for now. Just ignore that. So we're looking at example 1. We're going to verify that x plus 2 is a factor. So if we read is a factor, is a fact. I'm so used to writing so low that I just did that. Is a factor. I have a habit of writing now like an inch below where I'm supposed to write. Now I can't actually draw, my brain won't draw where I'm supposed to draw. I've been like, my brain.
You should recalibrate.
Is a factor means the remainder is 0. So that's how we're going to verify it. If it's a factor, when we plug it into remainder theorem, we're going to get a remainder of 0. If we don't, then it's not. Okay? We have x plus 2, so we're going to plug in x equals negative 2. So f of negative 2 equals negative 2 cubed plus 5 times negative 2 squared plus 2 times negative 2 minus 8. Negative 2 cubed is negative 8 plus 5 times 4 is 20 plus 2 times negative 2 is negative 4 minus 8. And so we get negative 8 minus 8 is negative 16 minus 4 is negative 20 plus 20 is 0. And you just prove that it's a factor.
So it's factor equals 0.
The factor is the remainder is 0. Yep. So instead of saying later on, instead of saying the remainder is 0, they rarely write the remainder. You know how yesterday when we solved for k or we solved for m and n, and they would have to give us the factor and then they give us the remainder? Well, now they'll just say x plus 2 is a factor. So if they say x plus 2 is a factor, you could cross out and write remainder 0. So that's how they tell you the remainder is 0. A lot of people will sit there and be like, you didn't tell me what the remainder is. I'm like, yeah, but I did. You're like, no, you didn't. I'm like, yeah, but I did. So if it says is a factor, you could basically cross that out and write remainder 0, because that is what they're telling you without saying remainder 0. Okay? Awesome. So we're going to learn how to factor it. All you're going to have to write is this.
Oh, now you're back to normal. That's good. I've done
Back to this. Okay, so if it says factor, ultimately in the end, when it's said to factor in grade 10, you would get your 2 little factors, right? Or you take out a GCF, or you do decomp, or you do difference of squares, but you'd have these little factors at the end. No. Okay, so if it asks you what are possible like factors or possible x-intercepts or anything like that, your possible zeros are based on, this back number here. So it's the factors of the back number, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And if we didn't have a calculator, we would test those numbers, all of them, all 8 of them. We would test them, and we would test them until we got a remainder of 0. Because remember, if we get a remainder of 0, it's a factor. So there's got to be a better way. So what I'm going to tell you to do instead is go into your calculator and type in y equals x cubed plus 2x squared minus 5x minus 6 into your calculator. Into your y equals. So we're going to use negative 3. So paying close attention so you're not completely lost on how to do synthetic division. So I'm forewarning you right now. We are going to do an L. We're going to do an L. The L is going to fit 2 rows of numbers in it. So if you make a very narrow depth L, like one little like line on your piece of paper, you're going to be writing really, really tiny, okay? So when you make your L, leave 2 lines with the L. So you're going to leave this in the corner, and then I'm going to leave 2 lines because I'm going to have a row of numbers here and a row of numbers here. Okay? How do we what? So when you put into your y equals and you put this into your y equals, and then you go second graph to the table of values, you have to pull off one of the x-intercepts. So one of the numbers where y equals 0. Yep.
I did 3 lines.
You're a rebel.
No,
Without a cause.
There's 3 of them, so it might be easier. Yeah.
Anyways, so, yep. Yes. Okay, so we have to make sure we can count down. 3, 2, 1, 0. So we can count down, so that's good. So then we don't need any placeholders. If we were missing the x or the x squared, we'd have to put a 0 in its spot, okay? So now all we do is the synthetic division is going to not contain the x's. It's just going to contain the coefficients. So what's in front of here? A 1. So we're going to have 1, then 2, then negative 5, then negative 6. This will seem overwhelming at first. It's very easy, but it will seem because we're going to be doing drop down, multiply, add, multiply, add, multiply, add, multiply, add, and it confuses people. You just need practice. It's not hard, okay? It just seems confusing at first. I'm forewarning you. So the first thing we're going to do is we're going to, and we always use the root here. So I always go like this, x equals negative 3 so that I remember that it's the root. So what would the factor actually be? And I put that above it so that I have both. So the first thing you're going to do is you're going to drop down the 1. Okay? Just drop it because that's what you do. All right. Then you're going to multiply these. Negative 3 times 1. Negative 3 times 1 is negative 3, and you bring it up here. So all we're going to do is we're going to do drop down, and then we're going to multiply, add, multiply, add, multiply, add till we're done. Okay, so we multiplied. So now we're going to add. 2 plus negative 3 is negative 1. So we've added. So now we're going to multiply. Negative 3 times negative 1 is 3. I never draw these arrows. I'm just drawing them so you can see this. It looks really confusing when you draw the arrows. So then we've multiplied, so now we're going to add. Negative 5 plus 3 is negative 2. Then we're going to multiply. Negative 3 times negative 2 is 6. And when I add these, I get 0. And I box this. The back number is always my remainder. If it's not 0, you messed up because you said it's a factor. Remember, if it's a factor, what's the remainder? So if when you do synthetic division and you picked a factor off and you don't get 0, you messed up. So often it's just that someone pulled the y-intercept instead of the x-intercept. Okay? So now we're left with 1, negative 1, negative 2, right? These are our numbers down here. Remainder 0, technically, correct? Well, we took our x's out. We have to put our x's back in. Now remember, think about this. When you have an x squared, it breaks down into two x-intercepts most of the time, right? So what ends up happening is if you divided one x-intercept out, one factor out, you'd be left with just a single factor. So when you write these out, you guys, you're always left with one less. So this is x cubed. This one, I've pulled an x out already, so this one's actually going to start at x squared, and then you just go down x, and then that. So when you insert the letters back in to this here, it's always one less because you took a factor out, right? You took an x out, so now it's an x squared. And then we have to be able to factor. You have to be able to do your decomp and product sum still, because at this point, once you get it to this point, you have to be able to factor it like you did in grade 10 and 11. So you'd say it's product sum because we have a 1 in front, so we can go right to brackets. If this was a -1 or a number, you couldn't go brackets. You'd have to do decomp, right? So we have an x in the front, and then we have to figure out what times what equals 1 times -2, so -2. So these two multiplied together. And then what plus what equals your middle term, -1. -2 and +1. So x minus 2, x plus 1. And so my answer is the factored form of that because I want you to factor it. So the factored form of that is this, but I also have to add back the x plus 3. Everyone forgets to bring this back down. So that's actually the factored form of the above. So until this very moment, we could only factor as high as up to x squareds, right? That was what we were taught in 10 and 11. Well, remembered in 11, taught in 10. Now we'll be able to factor up to anything, but they'll make us only factor up to x to the 5. Okay? Now,
well, why won't we just plug it into our calculator?
Because some of them aren't going to be, some of them will be a fraction. Some of them won't factor fully. So if you got to that point where it was x squared minus x minus 2 or whatever it was, if you got to that point and you couldn't factor it, say it was x squared plus 3x plus 7, there's no way you can factor that, then you would just write that factor and the original factor. So you'd have x squared plus whatever I said, 3x plus 7, and in front of it you'd have the factor that you divided your synthetic division by. So that's how they'll do it, so that you can't just pull from your calculator. Okay. Or they'll say where to make an error, stuff like that. So what are my possible values that I put in front of my synthetic division symbol? What are the possible roots? Plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. My possible ones, if it ever says possible, then it would be any of those. So if it said what could the factor be? Yeah. Because it's the values of your constant at the back. It's the factors of your constant. So your constant is 15. So plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. Because you'd have to be able to divide something in evenly into that back number to get a remainder of 0, right? So that's why you can use those numbers. If it was something else, you'd never be able to divide it evenly to get that to go away. So plug it into your calculator. Yeah. It would ask, it could say, what is the possible factor? And when you plug all 4 in, they actually don't get you a remainder of 0 at all. But the moment I say possible, as long as the factor is one of the constants, you can pick it. So absolutely, there could be a question. It would be more possible, though, right? Like not what is the factor, because if it was the factor, then it would have to be a remainder of 0. If it says possible, then it would be one of those numbers. So plug it into your y equals. First person who gets an x-intercept, spout it out, and I'm going to use it. -5. People agree with this statement. Okay. I was like, well, I don't want to do a big synthetic division. I always ask for 2 people. Mm-hmm.
Yeah.
He picked -5. That's kind of an ugly one to use, but we'll use it nonetheless.
Let's use,
No, we're going to use -5. Okay, make sure we always have to ask ourselves, can we count down? Because where's the other place that people screw up? First off, they take the y-intercept by accident. That's one oopsie. The second oopsie is not putting a 0 placeholder. Okay? All right. So 3, 2, 1, 0. We can count down. So we just put the coefficients. 1, 9, 23, 15. Okay. Drop the 1 down. Multiply. Negative 5 times 1 is negative 5. Add. 9 plus negative 5 is 4. Multiply. Negative 5 times 4, negative 20. Add. 23 minus 20, 3. Multiply. Negative 5 times 3, negative 15. Add. 0. When you get the 0, you have no idea how happy your heart feels because you're like, oh, I did it. It worked out. When you don't get the 0, you're like, oh my gosh, what did I do? Usually it's you forgot a placeholder. Honestly, if you didn't get a 0, it's usually that you didn't remember to put a placeholder. So this is an x cubed. So this is going to be 1x squared plus 4x plus 3. I forgot to do what I normally do, sorry. This is normally x equals negative 5. So what's the factor usually? And by usually I mean always. It's going to be x plus 5. Now we have to factor that x squared plus 4x plus 3. And honestly, what I do, because I'm very bad at remembering to rewrite that factor from the synthetic in my final answer, I'll go way down here and I'm going to put x plus 5 down here so that I remember when I factor this out that I have to make it join that. Like I'll put it at the end of my answer so that I remember to make it join because I always forget to make this join there. So we have x squared plus 4x plus 3. So we can do product sum. What times what equals 1 times 3, which is 3. What plus what equals 4, the middle term. 3 and 1. Now, if you're someone who still can't factor, you have to come in. You have to, like, there's a point in life where you're going to have to admit that you can't factor. This is that day. This is the time. You have to come in and admit it so you learn how to do it. Okay? Because we're going to be factoring trig equations. So you have to be able to factor. So x plus 3, x plus 1, make them join this. And we have our answer. Okay, you try B. There's a hint.
What?
It's missing the x squared. So what am I going to have to put in x squared's place? A 0. Try it out. Okay, so I'm going to pick 5. My possible factors would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 5. And if I took away your calculators, you'd have to test each one of them out till you get a remainder of 0. Okay? So 1, placeholder of 0 for x squared, negative 27, and a 10. Drop the 1. 1 times 5 is 5. Add it. 0 plus 5 is 5. 5 times 5 is 25. Add them. Negative 27 plus 25 is negative 2. 5 times negative 2 is negative 10, and then I get happy because I see that I get 0. So x equals 5, so my factor is x minus 5, so I'm going to add it back here. Now, this is going to be 1 less, so if it's x cubed, this is x squared plus 5x minus 2. Okay? Can I factor that? Is there anything that multiplies to give me 2 and adds to give me 5? No, I'm done. Because it says factor, I'm done. Because it says factor. If it said solve, I would have to put this in the quadratic formula. Because solve means x-intercept. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. It's on your formula sheet at the very top left. Yeah, you will tomorrow. So today I'm going to give you questions that are just up to x cubed. The beginning of class tomorrow, we're going to do some x4 and x5. The catch is, if you have an x4, you're going to have to do synthetic division twice. If you have an x5, you have to do synthetic division 3 times. You have to do it until you get to that x squared at the bottom that you can do product sum or decomp. Okay? Remember, if when you have a trinomial, so 3 terms, that the first term is not a 1, so if it's a -1, or if it's a number of any sort, you have to do decomposition. You cannot just go bracket x plus something, or x minus something, x minus something. That is a common error that happens on the test, and then people get their questions wrong. You can't do that. You have to decomp. So you have to replace your 2 middle terms, then group, then pull out, and then pull out the GCF, and then write your 2 factors. Okay, so it's more work. So keep that in mind. So we're going to do the x4s and x5s tomorrow. This is not all homework because I can't assign it. Tomorrow I'm going to check yesterday's and today's, so make sure you finish it. So for now, just do 2AC, 3AC, 4AC. Nope. Those ones are all really quick. They're not actually synthetic division ones. These are the synthetic division ones. 5AC, 6AC. For today. Tomorrow you'll be added more.